to see the first problem. This is, there are 4 lines on a plane such that no 2 of them are parallel and no 3 of them are concurrent. If their point of intersections are joined, then find the number of fresh lines thus formed and find a formula for n such lines. See, if you go through the first sentence, there are 4 lines on a plane. The 4 lines may be parallel, may be intersecting, 2 are parallel, 3 are concurrent, something like that. But the restriction given there is the 4 lines are such that no 2 of them are parallel, no 2 of them are parallel and no 3 of them are concurrent. And what does it mean? All the 4 lines are such that each line intersect the other 3 lines, if you take the case of 4 lines. Okay. Now, how such lines will be? Now, this is 1 line, 2nd line, 3rd line. Now, 4th line should be like this, because it is given that no 2 of them are parallel and no 3 of them are concurrent. You know the concurrency. Concurrency means they meet at a same point. It is not like this. And 2 parallel means they should be like this, but no 2 of them are in this shape. So now what the lines should be, how the line should be? The line should be like this. 3 lines or like this, and the 4th line intersecting the other 3 lines. Okay. Now the question is, their points of intersection are joined. This is point of intersection. These are points of intersection. Okay. Now, how many points of intersection are here? 4 lines are there. 4 lines are there. 1, 2, 3, 4, 5, 6 points of intersection are there. Okay. What does it mean by 6 points of intersection? 4 lines taken 2 at a time. 4 lines taken 2 at a time. They intersect in how many points? 4 into 3 upon 2. It is nothing but, you can understand, it is 6. Count it, please. This is 1, 2, 3, 4, 5, 6. 6 points of intersection are there. Now, what the question is, all these points of intersection are joined. This is 1 line, and this is another line. This is another line. So, how many fresh lines are formed now? 3 fresh lines are formed. Now, we have seen it through general drawing with a general understanding, but you have to now apply the combination. So now, what should be the combination here? How combination can be applied? To form a line, how many points we need? To form a line, how many points we need? We need 2 points like this, 2 points, 2 points, 2 points, 2 points like this. So how many points of intersection are there? 4C2 points of intersection are there. That's what I have shown here. 4C2 is nothing but 6. So if I choose 2 from this one, 6C2, then I must get the fresh lines. Let me see whether I'm getting it or not. 6 into 5 upon 2, which is nothing but 3 times 15. If you choose the lines, if you choose the points of intersection 2 at a time, you're getting 15 here, but you have only 1, 2, 3 here. Only 3 there, but you're getting 15 here. That means you're counting something extra in this one. What is that extra? That extra is to be subtracted to get the exact answer. So what I'm doing now in this one, I'm checking out whether all these lines are fresh lines or older lines also there. So let us see that. If you take points of intersection, this is an older line, 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 and this is an older line, this is an older line. All these are older lines that are also included in this one, because we have taken 2 points at a time, 2 points at a time, and we have written like this. With these 2 points, if you take from 6, you are getting 15 lines, which are not 15 but only 3. So how do we think? Now you have to count the number of old lines and they are to be subtracted. You have to count the number of old lines and they have to be subtracted. So think most generally. Let me take this line. If I take this line is intersecting this line in this point, and this line in this point, and this line in this point. So the fourth line, let me say, is intersecting the remaining three lines in how many points? 3 points. Understand that? 3 points. Now from these 3 points, how many lines are formed? How many lines are formed? It is common sense. We'll apply combination now. But for the most general understanding, I'm explaining you this. This is one line, this is second line, and this is third line. The entire line is third line. And this part is second line, this part is third line. So one line is created as 3 lines in this one. So that means this line is intersecting the remaining 3 lines in 3 points, and thereby you are getting how many older lines. By taking 2 points at a time, you have to write that. That is, one line is creating 3C2 older lines. What is this 2 here? You have to form a line, you have to take 2 points. From 3 points, I have taken 2 points. So this line is creating 3C2 older lines. 3C2 older lines. 3C2 is nothing but 3C1. How? This is also important. You have to remember NCR is equal to NC n minus R. So 3C1 lines. So for one line, you have got 3C2 line. For second line also 3C2 older lines. For third line also 3C2 older line. For fourth line also 3C2 older lines. That means each line is creating 3C2 older lines. Now 4 lines will create 4 into 3C2 lines. Understand it? So what is 4 into 3C2? 4 into 3C1. 3C2 is nothing but 3, it is minus 12 is how much? 3. What the exact answer we need there? Understand it better way. What is this 4C2? 4 lines are there. We want to count the points of intersection. How many points of intersection are there? 4C2 points of intersection are there. 4C2 is nothing but 4 into 3 upon 2 is nothing but 6. From this 6 points of intersection, only the lines should be formed, and we have taken 2 at a time, but you're getting 15 there. And if you see practically, there are only 3. The reason is, in this 6C2, the older lines are also included, so you have to subtract the older line. So that is why what I'm doing, I'm checking it out with this line. This line is intersecting the remaining 3 lines in how many points? 3 points. From these 3 points, how many lines can be formed? 3C2 lines can be formed. So each line is forming 3C2 lines, and 4 lines will form 4 into 3C2, which is nothing but 4 into 3, 15 minus 12 is equal to 3. Okay, now the continuation, that one, fresh lines thus formed or nothing but 3. Nothing but 3. So what is the continuation? Find the number of fresh lines thus formed and find a formula for n such lines. And we need a general formula for that one. For 4 lines, we have derived it. For 5 lines, what should we do? For 6 lines, what should we do? The same can be applied, of course, the concept. That is why I explained to you. And if you can write it for n lines, it can be taken as a general formula. So if there are n lines like this, that means instead of 4, you have n. So that is nothing but NC2 points of intersection will be there. Understand it, please. NC2 points of intersection. Here 4C2 means 6. NC2, don't see that as a formula. It is nothing but an integer. It is nothing but an integer. So NC2 points of intersection will be there. From this NC2, which is 4C2 is nothing but 6. 6 is taken to be 2 times. That is 6C2 combination. Similarly, NC2C2. NC2C2 lines are chosen, but in this one, like in this one, the older lines are also included. That is why you have to subtract the older lines. And how many lines you have here? 4 in this case, but we need a general formula for n lines. That 4 becomes, in this case, n into. Now, because 4 lines are there, this is nothing but, I say, 4 minus 1. Each line intersect the remaining lines. That means one line, because 4 lines are there, this line intersects remaining 3 lines. That means n lines will intersect n minus 1 lines. And from that one, how many points are to be chosen? n minus 1 C2. This is to be simplified now. This is n of n minus 1 upon 2 C2 minus n into n minus 1 into n minus 2 upon 2. So this, if you simplify, you will get the answer is this is n of n minus 1 into n minus 2 into n minus 3 upon 8. You can see the answer there. Here the answer is 3 for 4 lines. For n lines it is n by 8 into n minus 1 into n minus 2 into n minus 3. You can check it out for this one also. If you put n is equal to 4 here, 4 into 3 into 4, put n is equal to 4. It is 4 by 8 into 3 into 2 into 1. How much it is? It is nothing but 3, which is coinciding with this one. So this is a general formula you can remember. Even if 10 lines are given, put n is equal to 10 there. If 10 lines are given, put n is equal to 10 there. This is an important model problem. And understand, all these problems, if you are working out carefully, you know, you must have strong foundation in the basic level problems also, because you have to qualify first yourself in the JEE main, which will be of a previous IIEEE standard, because CBSE will be giving that examination. So you must be thorough in this level first, and if you qualify yourself in the first 1.5 lakh students, then only you will be eligible to take IIT JEE advanced level. So if you do not come under reservations, then you must be top 75,000 students of the country. And if you have any such, then you must be top 1.5 lakh students of the country. So that is why you must be aware of the basic problems also. You must be aware of the basic problems also. Okay, so you take this one now as a geometrical problem and prepare yourself. Be strong in the basic level. Okay, now if you see the another problem, please see the second problem, that the sides AB, BC, CA. If you see the second problem there, the sides AB, BC, CA of a triangle ABC have 3, 4, and 5 interior points respectively on them. That is A, B, BC, CA. And AB has 3 points on it, and BC has 4 points on it, and CA has 5 points on it. Do you understand that? So now what is it we find out? Interior points respectively on them, the number of triangles that can be constructed using these points as vertices. You must find out the number of triangles that can be formed. To form a triangle, how many vertices you need? You need 3 vertices. Most general thing you can understand. So let us see how many points are there total. 3 plus 4 plus 5, C. Correct or not? Total points we have taken 3. These many triangles must be formed with all these points. But understand, among these 3 points are collinear. These 4 points are collinear, that means they are lying on the same line. 5 points are collinear, they are lying on the same line. That is why they are to be subtracted, because these 3 points will not form a triangle. These 4 points will not also form a triangle. These 5 points will not also form a triangle. So from 3 points, how many triangles can be formed? It is 3. That means only one triangle will be formed, which will not be a triangle, but it is a line. That is why you have to subtract that. Minus, if you say 4 points here, this is minus 4C3, because 4C3 triangles will not be there because they are lying on the same line. Similarly, minus 5C3. Minus 5C3. So if you simplify this, it is 12. It is 5 plus 4, 9, 12C3 minus 1 minus 4C3 is another minus 4, 5C3 is another 5C2. 5C2 is nothing but 10. So this is 12C3 is nothing but 12 into 11 into 10 upon 3 into 2 minus 5 minus 10. If you simplify this, it is 222 into 10, 220 minus 15, which is nothing but 205. 205 should be your answer. That is the second option. Okay, the geometrically you can apply the combinations in this way. We have more and more to discuss in combinations. So among them, I've taken first application. Like I have named it as an application just for the sake of covering all the applications. Let us take this as application 1. What is the application 1? You can go through the slide there. Just go through that. The total number of combinations of P1 plus P2 plus so on plus Pk things taken any number at a time. When P1 things are alike of one kind, P2 things are alike of second kind, and so on. Pk things are alike of kth kind is P1 plus 1 into P2 plus 1 into so on, Pk plus 1. Just you say this in this way. On your dining table, a fruit basket is there. In the fruit basket, let me say, there are 12 bananas. 12 bananas means they are all like things. You can understand? They are all like things. Let me say 6 apples in the same fruit basket. 6 apples. And let me say there are some 7 oranges. 7 oranges. Okay? Should I repeat? There are 12 bananas and 6 apples and 7 oranges. 12 bananas, 6 apples and 7 oranges. Now you are given an option. You are given an option that you choose any number at a time. You choose any number at a time and you can take the fruits. Okay. Now, let us start with bananas. You like bananas, let me say. Then you can take 1 banana or 2 bananas or 3 bananas or 4 bananas. And if you are a Bhimsen, you can take all the bananas. So how many are there totally? 1 to 12 options are there. You can take 1 or 2 or 3 or 4 or so on, and 12. If you are a girl, you are more conscious about your calories, then you never take a banana. Okay. Then how many options are there? Then 12 plus 1 options are there. Understand it? What is that plus 1 there? Avoiding banana. So, first operation can be performed in how many different ways? 12 plus 1 different ways. Understand? So, you like apple, let me say. Then apple, 1 apple can be taken, 2 apples can be taken, 3 apples can be taken, 4 apples can be taken, 6 apples can be taken. But if you don't like apple, you need not have to take anything. You can avoid the apple. So, apples can be chosen in how many different ways? 6 plus 1 different ways. And there are oranges. Similarly, oranges, you can understand, they can be taken in 7 plus 1 different ways. Okay, now, all these operations can be performed in how many different ways? 13 into 7 into 8 different ways you can perform the operations. You can choose, you can select the fruits from the fruit basket. That's what it is. Simple, very simple. There are P1 things are alike of one kind like bananas. P2 things are alike of one kind like apples. And P3 things are alike of third kind, that is like oranges, and so on. Pk things are there. Then all these things can be taken can be taken or selected in how many different ways? P1 plus 1, P1 plus 1, P1 plus 1 into P2 plus 1 into P3 plus 1 and so on into Pk plus 1 different ways. What for this plus 1 stands? Plus 1 stands for not taking anything. Not taking anything is also included in this one. Okay. Now, how do we apply this to get the number of divisors? The number of divisors or the number of factors of a given number. Number of divisors or number of factors of a given number. And at pace, I will cover to find out for the better understanding. I'll take a number, smaller number 36. Before that, yesterday, Aishwarya has sent some problems. So I have received that mail and I didn't find time to answer that. You'll be receiving the answers by tomorrow. Okay. Now, 36 let me take. Now I am interested in how many factors does it have. At first, let us write 1 into 36, 2 into 18, 3 into 12, 4 into 9, 6 into 6. How many total number of factors are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 factors are there. How many are there totally? 9 factors are there, understand? Now, because it's a smaller number, you can write the number of factors like that, but I need the general formula to apply the combination. That is why what I'm doing, I'm prime factorizing it. This is also called to be canonical form or prime factorization. What is prime factorization? You have to split it into prime factors. That is, it is 2 square into 3 square. Now, 2 like things. 2 into 2. 2 like second kind. 2 threes are there. 2 twos are there. So, now you can observe all these factors. All these factors are either formed with 2, with 1 2, or 1 3, or 2 2s, or 2 3s, or 1 2 1 3, like that. All these factors are formed with only this one. So, let us now apply the same concept for this one. What is it? I will choose 1 2, or I'll choose 2 2s, or I'll choose 3 2s. 3 2s are not there. You can choose only 2 2s. Okay. I can choose 1 2 or 2 2s or no 2s. That means what? 2 plus 1 ways. Then I'll choose 1 3 or 2 3s or no 3s. So how many are there? 2 plus 1 ways are there. What is 2 plus 1 into 2 plus 1? It is 3 into 3. It's nothing but 9. So understand it, whenever a number is given like this, capital N, let me say it's a natural number. If you want the positive divisors or positive factors, then you have to prime factorize this. What are the prime factors? You know, it is 2 power P1 into 3 power P2 into 5 power P3 into 7 power P4 into so on like this. You have to prime factorize the given number. Then number of factors or divisors, both are same, is given by the power plus 1. Okay, so here, what is the power of 2? P1 plus 1 into P2 plus 1 into P3 plus 1 into so on. This will give you the number of factors or divisors of the given number n, like this. Let us apply this to a problem which is there. It is forward. Next. Yes. Find the sum of odd divisors of 2160. What does it mean? Find the odd divisors of 2160. Sum I have given there, not the number of odd divisors. But from this formula, you can now find out the number of even divisors and the number of odd divisors. How is it possible? Let me say. Now, if you want even divisors of this one, let me say simple example. If you want an even divisor, every even divisor is divisible by 2, you know that. So how many? Let us count it because it's a simple number. 1, 2, 3, 4, 5, 6. How many even divisors are there? 6 even divisors are there. Now I want to see that through a formula. So every even divisor, you know, it should be divisible by 2. That is why what I'm doing here, I'm taking 2 common. That is, I'm taking 1, 2 out. Then what should be remaining? 2 power 1 into 3 square. Whatever the factors you write for the terms in the brackets, every factor will be definitely multiplied by 2 because I need even divisors. So now apply the same formula for this one now. For this one, by separating 1, 2 out. So it should be 1 plus 1 into 2 plus 1, which is nothing but 3 into 2, which is nothing but 6. 1, 2, 3, 4, 5, 6. That will give you the number of even divisors. So in this formula also, you can understand number of even divisors is equal to, number of even divisors is equal to, you separate 1, 2. That is, you take 1, 2 out. Then this power becomes P1 minus 1. P1 minus 1. Then apply the formula. P1 minus 1 plus 1. What will it be then? P1 into P2 plus 1 into P3 plus 1 into so on. Because among all the prime factors, among all the prime numbers, only one prime number is even. You know that it is only 2. It's only 2. Okay, so that is why we have taken 2 and we have written, so the number of even divisors. Similarly, the number of odd positive divisors, of course, you have to write it as positive divisors, number of positive factors, number of even positive divisors, number of odd positive divisors. What should it be? Odd positive means it should not be divisible by 2. Avoid 2 totally. Avoid 2. I'll tell you like this. How many odd are there? 1, 2, 3 are there. 1, 2, 3 are there. So avoid 2. What is the power of 3? 2. 2 plus 1, 3. That's what it is. 1, 2, and 3. That's what it is. So you totally avoid the 2 power P1 and write the same formula for this one, starting from 3, it is P2 plus 1 into P3 plus 1 into so on. This will give you the number of odd divisors. Okay, so number of even positive divisors, number of odd positive divisors, and you know the number of trivial divisors. Trivial. How many trivial divisors are there? Trivial divisors are nothing but the number and unity itself are said to be trivial divisors. For every number, you will have 2 trivial divisors. How many non-trivial divisors will be there? Minus 2. How many are there? 9 factors are there. If you want non-trivial divisors, you have to avoid these 2. Then it should be 9 minus 2, 7. Understand this. Trivial, non-trivial. Trivial means the number itself and the unity are said to be trivial divisors. Non-trivial divisors means find out the total number of factors and minus 2. So this will give you the even positive divisors and the odd positive divisors. Now we are interested in getting the sum of this. Sum of this. How to get the sum here? You'll get a geometrical sequence, very interesting geometrical sequence in this case, and we want the sum of these divisors. Let me say 1 plus 2 plus 3 plus 4 plus 6 plus 9 plus 12 plus 18 plus 36. Okay, now let me write this in this way. 1 plus 2 square. Next, let me take this. Then you can take 3 common. What will you be getting then? 1 plus 2 plus 3 taken common, 4, 2 square. Next, I will take this 9, 18, 36. In this 3, I can take 9 common. It is 1, it is 2, it is 2 square. So what will you get here? 1 plus 2 square into, again, if you take this common, 1 plus 3 plus 9 is nothing but 3 square. So you can say it's a geometrical sequence, which is nothing but 2 cube minus 1 upon 2 minus 1 into 3 cube minus 1 upon 3 minus 1. What should be the sum in this case now? The sum should be like 2 cube minus 1 means it is 7. It is 27 minus 1, 26 by 2, it is 13. The sum is 91. The sum is 91. You can check it out. You can check it out. This is if you add all this, you will understand it is 91. You'll get 91. You can check. You can try it. You can try it. So what we need here to generalize this formula, this is 2 cube. Matlab means 2 power 2 plus 1. 2 power 2 plus 1 minus 1 upon 2 minus 1. 3 power 2. 3 power 2 plus 1 minus 1 upon 3 minus 1. Understand it, please, carefully. That means 1 is added. 1 is added. Okay. So for n, you can now say. Can you say? Anybody? Please. Sum of all the factors or divisors. Can you try it? All the divisors or factors is equal to, this 2 square becomes 2 cube there. So 2 power p1 becomes 2 power p1 plus 1 minus 1 upon 2 minus 1. And 3 power p2 becomes 3 power p2 plus 1 minus 1 upon 3 minus 1. 5 power p3 becomes 5 power p3. 5 power p3 plus 1 minus 1 upon 5 minus 1, and so on. This will give you simply the sum of the divisors. Then sum of the odd divisors, sum of the even divisors. You can understand. Sum of the odd divisors means you avoid the 2 power p1 and write the same formula. Avoid 2 power p1 because that will make any number even. Because it's an even number. If you multiply any number with the even number, that becomes again an even number. So if you need the sum of odd divisors, then avoid this and apply the same formula. That means this will be avoided, and from this one the formula starts. Similarly, if you need the sum of even divisors, then avoid 1, 2. That is, take 1, 2 out and write that out and apply the formula for the remaining one. That means 2 will be out and p1 plus 1 becomes p1 only. p1 plus 1 becomes p1 only. So like that, the same concept can be applied to the number theory in this way.